As you can see, this is called Evaluating Limits Part 1. All right, so let's say we were given a limit. And let's say that something like this was dropped on us. Okay, now, yes, you could graph this function and walk near x is 2. But what we're trying to get you to learn is that your first instinct should be to plug this number in for x. And if you get an answer, then you are done. Okay, so what I'm going to do is I'm going to plug in 2 everywhere I see an x. And what we're going to end up with is 2 squared 4 plus 6 minus 4. So this is 6. That is my answer. I am done. That's the whole problem. Now, why did that work? Why was that so simple? Because this function is continuous everywhere. And the fast way of saying that is continuous on the real. So this is continuous everywhere. So if you ask me about the point number 2, or what's the y value at x is 2, it's like, dude, this is continuous everywhere. It's just the y value. Okay. So does that pretty much always work? Yeah, if your function is continuous at that spot, it will work. Even if it's a little bit funky. How funky? I mean, I just made one up. Limit as x goes to 1 of e the x minus 3 over x plus 5. It's like, plug in 1. If you get an answer, that's the answer. So in this case, my answer would be e to the first minus 3 divided by 6, whatever that decimal equivalent is. Yes, this function will have a problem spot at -5, but that's not where I'm walking. It's continuous at x is 1. That's why I got an answer. All right, let's do one more. Maybe this one won't be as funky. All right, so let's go the limit as x approaches 0 of sine x plus 2 cosine x. Okay, so if I plug in x is 0, the sine of 0 is 0. The cosine is 0, and by the way, we're talking about 0 radians. The cosine of 0 is 1. So I'm going to get 0 plus 2 times 1, which is 2. All right, so if you plug in your number and you get an answer, congratulations, you are done. The function is continuous at that spot. All right, in the next couple of videos, we're going to be looking at funky spots.